All right, so we're just going to go through the review for Unit 11. So this first part, we are going to be just stating which form the quadratic is given in. So remember, standard form is ax squared plus bx plus c. Vertex form, a times x minus h squared plus k. And factored form, we have x plus root 1, x plus root 2. Actually, I should say x minus root 1, x minus root 2, technically, because when you actually find the roots, they're the opposite side. But either way, so if I have two sets of parentheses, that's going to be factored form. If I have one set of parentheses with a squared, it's going to be vertex form. And this one is going to be standard form, so standard, factored, vertex. Again, two sets of parentheses, so factored. Vertex forms one that has the parentheses squared, and standard. All right, so we want to state the vertex, the axis of symmetry, the concavity, and whether that vertex is a max or a min. And then we're going to draw the axis of symmetry. So let's actually just start out by drawing this quickly. So remember, plus 4 on the inside goes left 4. Plus 2 on the outside goes up 2. And the negative out front is a reflection or flip across the x-axis. So this is going to go left 4 and up 2. So there's the vertex. So the vertex is at negative 4, 2. It's going to be opening downward. So it is concave down. And that's because the negative out front. The axis of symmetry, we'll call it AS, is at x equals negative 4. Okay, remember it's always at the x value of the vertex. It's that line that is this line of symmetry there that cuts it in half. And what else were we asked here? Oh, okay, the vertex is a max here because it's higher than all the other points around it. And that's because it's been flipped. And we've drawn the axis of symmetry. Okay, number 8, it goes right 5, it goes down 5, and then the 2 is a vertical stretch of 2. So right 5, down 5. So there's my vertex at 5, negative 5. This one is positive out front, so it's going to open upward. The stretch is going to make it a little taller and skinnier. I probably should have accentuated that a little bit more, but that's okay. The vertex is a min that is concave up, or the parabola is concave upward. What else we need? Let's see. The axis of symmetry is always at the x value of vertex. And to draw it on there will be this dotted line that goes through the vertex. All right, number 9, identify the vertex and state whether it is a max or min. So we're doing the same thing as before. It's just that we are not needing to draw the graph or do these other extra things. So the vertex would be negative 4, since this goes left 4, and negative 9, since that goes down 9. So the vertex is located at negative 4, negative 9. 3 out front is positive, which means this thing is opening upward, which makes our vertex a min. This one's going to be a max, I can tell right away, because there's a negative out front and it's going to flip it. So our vertex point would be a max. And it's located at, since this goes right 6 and up 2, would be at 6, 2. All right, so now this part we're going to change the following quadratics from standard form to vertex form. So remember, vertex form is a times x minus h squared plus k. And in this equation, we are going to be finding a, h, and k. So remember, a is the same a that's in front on ax squared plus bx plus c. H is equal to negative b divided by 2 times a. And k is equal to the function evaluated at h. Okay, so here I'm going to have a times x minus h squared plus k. I'm putting blanks there. Put a, h, and k here to remind myself. A is equal to negative 2. H is equal to negative b, so that'd be negative 4 over 2 times a, which is negative 2. Okay, remember, evaluate the bottom before you divide. So this would be negative 4 divided by negative 4, which is 1. So I'll put a 1 there. Then that 1 is going to be plugged back into the function. So the function being the original here. So f of 1 would be equal to negative 2 times 1 squared plus 4 times 1 plus 1. Remember, always square here before you multiply by the number out front. So this would just be 1 times negative 2 plus 4 plus 1, which gives me 3. So negative 2 times x minus 1 squared plus 3 is the vertex form of the same equation here. I could put y equals out front. Okay, number 12, same thing. A is 1, so I don't really need to write anything in front. I can write it, I just don't have to, right? So we're going to find h and we're going to find k. So h is equal to negative b. So since b is negative 4 already, negative 4 would become positive 4 over 2a equals 4 over 2, which is 2. So h is 2. And then to find k, we're going to take 2 and plug it back into the function. So y equals 2 squared minus 4 times 2 plus 1. 4 minus 8 plus 1, which would be negative 3. So I get x minus 2 squared minus 3. Just kind of cleaning up from above. Okay, again, one more time. Here we have negative 1 out front. That's our a. H is negative 4 over 2 times negative 1, or 2. And k is equal to this function evaluated at 2. So negative 2 squared plus 4 times 2 minus 8. We get negative 4 plus 8 minus 8, which is negative 4. So negative 4 out here for y, and there's the vertex form. Okay, we're going to change to vertex form and sketch our graph. A is 1, so I'll just have a 1 out front. Don't need to write it, but you can if you want to. X minus, we have negative 8 divided by 2 times 1, which is negative 4. So here I'll have x minus negative 4, which becomes x plus 4. But I still plug in negative 4 to the function. Negative 4 squared plus 8 times negative 4 plus 14. So 16 minus 32 plus 14. So negative 16 plus 14, which is negative 2. Okay, now we can easily sketch the graph. We know that goes left 4 and it goes down 2. It's positive out front, so it's going to open upward. And there's the quadratic. Okay. On this one, a is negative 2, x minus h squared plus k. H is equal to negative 4 over 2 times negative 2. Negative 4 over negative 4 equals 1. And now plug 1 back in. Negative 2 times 1 squared plus 4 times 1 is negative 2 plus 4 equals 2. So I know this is going right 1, up 2. It's being vertically stretched and reflected, so it's going to be kind of a skinnier U, and it's heading downward. So that would be the graph. Okay, now we want to change to factored form. So in order to change to factored form, we're going to use x factoring. So a is 1, c is 27. If I multiply 1 times 27, I get 27. And b is 12. So I'm looking for two numbers that multiply to 27 and add to 12, which would be 9 and 3. So this is going to be x plus 9 times x plus 3. Okay, remember we always divide these by a. but since a in this case is 1, it's not changing anything. Okay, so this is the factored form of the equation, so that's part 1 here. We need to identify the y-intercept and the x-intercepts. In order to find the y-intercept, we're going to plug in 0 for x. This would be 0 plus 9. So we're finding the y-intercepts here, and that's when x equals 0, times 0 plus 3, which would just be 9 times 3, which equals 27. So the y-intercept is at 0, 27. The x-intercepts I find by plugging in y equals 0. So I'm just going to have 0 equals x plus 9 times x plus 3. We're solving for x. So if I set each of these equal to 0 and solve for x, I'm going to get x equals negative 9 and x equals negative 3. So there are two x-intercepts, negative 9, 0, and negative 3, 0. Okay. Identify the vertex, the y-intercepts and y-intercept and x-intercepts of each, and sketch the graph. So same thing here. So we have a times c, 1 times 35 up here. B is equal to 12. So 5 times 7 is 35, and 5 plus 7 is 12. So factored form would be x plus 5 times x plus 7. Remember, divide each of these by a, but in this case a is 1, so it won't change anything. To find the x-intercepts, we are going to set this equal to 0. So x equals negative 5 and x equals negative 7. So I know negative 5 and negative 7 are the 2 points that it's going to cross the x-axis. To find the y-intercept, I'm going to plug in 0 for x. So 0 plus 5, 0 plus 7 equals y. That would be 5 times 7 equals 35. So the y-intercept is going to be way up there. We can't really draw that on there, and that's okay. Now what we need to find is the vertex in order to finish drawing this. So we need to find HK, the vertex. So h is negative b over 2a. So negative 12 over 2 times a would be negative 6. So this is h. And to find k, we're going to take our function and evaluate it at h, which is negative 6. So negative 6 squared plus 12 times negative 6 plus 35. So 36. Let's see, I have my calculator here. 12 times 6, I should have known that, 72. So minus 72 plus 35. So 35 and 36 added together would be 71. So this is going to be negative 1. So my vertex is at negative 6 and negative 1. So it's going to do something like this. Once this gets up to 35, it's going to cross the y-axis, but we're not going to worry about putting that on the graph. Okay. All right, number 18. All right, so number 18, we're going to do the same process. We're going to start by x factoring. Here a is 1/4 and c is 4. So 1/4 times 4 is 1. So I'm looking for two numbers that multiply to 1 and add to 2, which would just be 1 times 1 or 1 plus 1. So this is going to be x plus 1 times x plus 1. But remember, I need to divide these each by a, and a is 1/4. If I'm dividing 1 by 1/4, it's the same as multiplying by the reciprocal of 1/4. So it's just 1 times 4. So it factors to x plus 4 times x plus 4. So x is equal to negative 4. It's a repeating real solution. Okay. So I know it's going to cross, actually just touch at negative 4. It doesn't cross when it's one real solution. Now we need to find the x-intercept and the y-intercept. To find the x-intercept, I'm going to plug 0 in for y. Oh, I did that already. Okay, so to find the y-intercept, we're going to go 0 where x's are. So it's going to cross at 16, 4 times 4. So that's the y-intercept. Okay, and then we need to find hk. H is negative b over 2a, so negative 2 over 2 times 1/4, which is the same as negative 2 times 1/2. Remember, turn this over and multiply, so negative 2 times 2 over 1 would be negative 4. And then we're going to plug that negative 4 into the function in order to get our k. So negative 4 squared plus 2 times negative 4 plus 4. So negative 4 squared is 16, and 16 times 1/4 is 4. 2 times negative 4 is negative 8, and plus 4, so this is just 0. So negative 4, 0 is the vertex. It's opening upward. It would be a bit wider than normal because of the 1/4. But there would be the graph. So on that one, I guess I could have saved myself some work, and knowing that there's only one real solution, it's going to have to touch there at that point instead of cross. So I guess I could have saved myself some work from finding the vertex. All right, we're going to use the information provided to write the standard form of each parabola. Okay, so remember, to find the standard form, we're multiplying everything out. The x plus 9 squared needs to be written out as x plus 9 times x plus 9. We're going to multiply the 2 into the first set of parentheses only. And then we're going to multiply that by x plus 9 and subtract 10. So 2x times x is 2x squared. 2x times 9 would be 18x. 18 times x is 18x. And 18 times 9 is, let me grab my 18 times 9 is 162. And then we'll subtract 10 from that. So combining like terms, 2x squared plus 36x plus 152 would be standard form. Okay, so number 7, same thing. 7 times x plus 1 times x plus 1 plus 4. So we'll multiply the 7 just into the first set only, would be 7x plus 7. 7x times x is 7x squared. 7x times 1 is 7x. 7x and 7 plus 4. Combining like terms, I'm going to get 7x squared plus 14x plus 11. Okay, on number 21, we have factored form. We're going to change to standard form, so we're going to just take and multiply the 3 into the first set of parentheses. So 3x minus 15 times x plus 7. 3x times x is 3x squared. 3x times 7 is 21x. Negative 15 times x. And negative 15 times 7 is, here, I can grab my calculator, 105. So 3x squared plus 6x minus 105. Okay, last one. Just go ahead and multiply it out. X squared plus 10x minus 8x minus 80. Combining the two like terms together in the middle. So x squared plus 2x minus 80. All right, so the next part of the review is some story problems. So I'll do a pause here and we'll get those story problems up. All right, so 24, the path a baseball takes after it has been hit is modeled by the function h of t, where t is time in seconds and h is height in feet. What was the maximum height the baseball reached? So if we think about the path that a baseball would take, it's going to be a parabola. The max height is going to be the vertex. So h here is like y and t is like x, right? So the time is on the x-axis, the height is on the y-axis. So when we find hk, which is the coordinates of the vertex, h is going to be the time in seconds, and k is going to be the height. So to find the max height, what we're really looking for here is k. All right. So start out by finding h, because we can't find k without finding h first. So h equals negative b, so negative 128 over 2 times a is negative 16. So negative 128 divided by negative 32 is equal to 128 divided by 32 is equal to 4. Okay, so it takes 4 seconds to reach the max height, but that max height is equal to k, which is equal to the function evaluated at 4. So negative 16 times 4 squared plus 128 times 4. So 16 times 16 times negative 16 is negative 256. And 128 times 4 is 512. And 512 minus 256 is equal to 256. So 256 feet would be the max height. How many seconds did it take the ball to reach this maximum height? Well, we already found that. That was 4 seconds, right? Because at that max height, t is equal to 4. So because h is 4 and k is 256. How many seconds was the ball in the air? So we want to know when it hits the ground, how many seconds have passed by. So what we need to do here is we need to set our equation equal to 0, replace the height with 0. So in order to actually solve that for t, we're going to have to factor this. It looks like since our constant term is missing, we can just factor this using the greatest common factor. So pull out negative 16t, and you'll have t minus, let's see, 128 divided by 16 is 8. So t minus 8. So there we have t equals 0. That's this one right here, right? When the baseball was thrown, when the initial height was 0. And we have t equals 8. It was in the air for 8 seconds. Okay. Your friend tosses a ball into the air at an initial velocity of 18 feet per second. The equation for the height is this. It models the height of the ball where h is height and t is time in seconds. How long was the ball in the air? So in order to find out how long it was in the air, right, we're looking for those x-intercepts. We're looking for when it started and stopped. We're actually looking for where it stopped. So we're looking for this x value here. So again, set it equal to 0 and solve for t. In order to solve for t here, we're going to have to x factor, get it in factored form. So negative 8 times 5 is negative 40, and b is 18. So we're looking for two numbers that multiply to negative 40 and add to 18. So that'd be 20 and negative 2. So 0 equals x plus 20 times x minus 2. We need to divide each of these by a, so negative 8. We'll reduce each of these fractions, so 20 divided by 8 is the same as negative 5/4. Negative 2 divided by negative 8 would give me a plus 1/4. So really I should have replaced these two signs with one sign. And then because I am actually solving here, I mean ordinarily if I'm just factoring I want to move these bottom numbers in front of x, okay? But on this one, because I'm actually trying to solve these, I'm just going to take and change the signs here. So x equals 5/4 is one solution, and x equals negative 1/4 is the other. So we would like the positive one since we're talking about time and how long this has been in the air. So 5 divided by 4 is 1.25. So it was in the air for 1.25 seconds. Okay, the maximum height of the ball, again, that's the vertex. That's the k value that we're looking for. So in order to find that, we have to find h, which is actually what part C is asking us, because it's at what time did the ball reach the highest point. So negative b would be negative 18 over 2 times a. So negative 18 divided by negative 16 is equal to, excuse me, so 1.125 seconds. And that max height can be found by plugging that 1.125 back into the function. So negative 8, 1.125 squared, plus 18 times 1.25 plus 5. Okay, which if you combine all these things together is equal to 15.125. So the maximum height the ball reached would be 15.125 feet. Okay, so moving on, let's see, number 26. One day at the beginning of a wonderful math class, Vanity was approaching her desk. She noticed that 2 flirtatious boys had left half-drunk fruity drinks and fruit roll-ups on their desk. In a moment of rage, she picked up the bottle and flung it toward the garbage. Where Heth was standing, the equation h of x, where x is time in seconds and h of x is the height of the bottle from the top of the garbage can, how long does Heth have to move out of the way and say, whoa, what is the max height that the bottle could get? Okay, so we have Mr. Mumford's creativity here. But basically it's just the same type of question as the previous ones. So it's asking us 2 questions. How long does he have to move out of the way? So because we're talking about when that thing hits the garbage can, right? We're looking for the x-intercept there, where it will hit the garbage can. And then the max height, again, we're looking for the k value of our vertex. Okay, so 2 things. So first, let's x factor this. So negative 16 times 3 is negative 48. And we're looking for 2 things that multiply to negative 48 and add to 10. So let's see. 24 and 2, 16 and 3, 12 and 4. Let's see. All right, so actually this is not factorable. There's no 2 numbers that multiply to negative 48 and add to 10. So instead we're going to need to use the quadratic formula. So we're going to find the discriminant first, which is b squared minus 4ac. So that would be 10 squared, which was 100, minus 4 times negative 16 times 3. So they have a negative times a negative here, so it's going to be 100 plus 4 times 16 times 3, which is 192. So the discriminant is 292. And then to plug this into the formula, we would have negative b, so negative 10, plus or minus the square root of the discriminant over 2 times a. A is negative 16. So square root of 292 is 17.08. So on this one, I'm not going to worry about keeping it in exact form because I'm looking for seconds here. So I'm going to want the positive solution here. So if I do negative 10 plus 17, I'm going to have a positive over a negative, which will give me the negative solution actually. So I want the negative one. Negative 10 minus 17.09. And then divide that by negative 32, and that's going to give me positive 0.85 if I round up. Okay, so The positive solution is 0.85 seconds, so that would be the amount of time he has to move out of the way, which is not a lot. And then we want the max height, which is again the k value. So first find h. H equals a negative b over 2a. So negative 10 divided by negative 32.3125. And then we'll take that and plug it into the function. And evaluate, 0.3125, not 1. Okay, and let me quickly stick that in my calculator, and that is equal to 32.69 feet. That is one heck of a high toss. Okay, so 27 Haid jumped in the air to chest bump race. The equation of the height off the ground is represented by this equation. T is time in seconds. How high does he get off the ground? So again, that'd be the max height. So we're looking for the vertex. We're looking for the k value of the vertex. So h equals -2 over 2 times -1, which is 1. So that's the time that it takes him to get to the max height. K is equal to -1 squared plus 2 times 1 plus 1. So -1 plus 2 plus 1 equals 2. So 2 feet is the max height he gets off the ground. All right, guys, we will take the test tomorrow. If you have any questions, please contact me through email and we can work on that.